In this video, I'm going to discuss how to set up limits of integration when we're integrating over what's called a polar rectangle. This is where your angle theta and r are both going to be just like numbers. So theta will change from a number to a number and r will change from another number to a number. That's called a polar rectangle. But what are theta and r and how do we determine them? All right, so what I'm going to assume is that r is positive. You can actually define r to be negative, but that's just the additional difficulty I don't need. So I'm just going to define r as the distance from a point to the origin, okay? And then theta is the angle with the x-axis. So with that said, if we look at this circle, if we get closer, first, we're going to fix a theta, okay? So when you fix a theta, then if you are over here at the origin, and then you go for a fixed theta, so angle theta is not changing, that's how your r is going to change, because r is the distance from the origin over here to the boundary, to the when it leaves like the region, right? So how does it change? So it's going to start over here where it's 0, and then it's just going to go all the way until it reaches that outside, which has the radius of 2. So that means that it's going to be 0 to 2 for r. Okay, so this is 0 to 2. For theta, that's going to change. So theta is the angle with the x-axis. So it's going to start here, let's say, right? And then you go to swipe the whole circle. You need to go all the way around, right? And so then theta is going to go from 0 to 2 pi for the whole circle. Okay, now if I want to go, so again, let's just go 0 to 2, and this will be 0 to 2 pi. What if it's the top half of a circle? How does it change? Okay, so again, to fix angle theta with the x-axis, then r is going to start at the origin, right? And then you go until you reach the boundary of the region. So here it's going to start at 0, and then it's just going to go all the way up to the boundary, which is 7. So this will go 0 to 7. What about the angle? How does that change? So remember, just if you don't remember the trigonometric circle, what has to happen is like over here, the angle is 0. On the top, that's pi over 2. Here, it's going to be pi. Then on the bottom, it's going to be 3 pi over 2. And finally, it'll go back to 2 pi or 0. It's the same thing, right? By the way, hopefully you also remember which you're going to need is the quadrants. So the quadrant, this is quadrant number 1, this is quadrant number 2, this is quadrant number 3, and this is quadrant number 4. So for the first quadrant, your theta would change from 0 to pi over 2. And you're going to need that because on the homework, I'll be asking you, you'll have to fill it out. If it's the second quadrant, your theta would go from pi over 2 to pi. And if it's the third quadrant, it'll go from pi to 3 pi over 2. And if it's the fourth quadrant, this is a little bit trickier. So here you can do either 3 pi over 2 or 3 pi over 2 to 2 pi. That's one way you can do this. And if you actually remember that if you add the 2 pi, it's like the same thing, you can subtract 2 pi. And here you can actually go from negative pi over 2 to 0. So that's another option for the fourth quadrant. I'm not sure which one the questions will ask you to do, so you can like try both of them. They're both supposed to be correct, but sometimes, you know, the computer is not smart enough to pick up both answers. So anyway, so here for this one, r will change from 0 to 7, right? Because the radius of the circle is 7. And theta is the angle with the x-axis. So here it's going to be, you know, from here where it's 0 up to here where it's pi, right? So this will be 0 to pi for theta. Now, the right half of the circle is going to be, okay, so here you're going to start at 0, and then you're going to go all the way until the end of the circle. So for a fixed theta, your r will change from 0 to 8, right? So this is going to go 0 to 8. And then what about theta? So here is a little bit also trickier, and I'm not sure what exactly it wants. So on the bottom, it's 3 pi over 2. On the top, it's pi over 2. But you're not supposed to do that because 3 pi over 2 is supposed to be less than pi over 2 because lower limit is supposed to be less than the upper limit for the interval. So that's going to be a problem. So I think what you can do is go from negative pi over 2 on the bottom to positive pi over 2 on the top. That way your angle will go from a smaller number to the larger number. So I think that's what it wants here, not 3 pi over 2 to pi over 2. That's not good. Okay, so we're going to actually check that in a second. By the way, if it was the right half of a circle, that'll actually be okay, because you would go from pi over 2, right? On the top, it's 90 degrees, and then over here, it's 3 pi over 2. That would work. Pi over 2 to 3 pi over 2, because that's the lower limit is smaller than the upper limit. Finally, this is the donut case. So what's going on with the donut? The donut is like between two circles. So again, for a fixed theta, I'm going to change from over here, right, to over here, right? My distance to the origin. So if I'm over here and over here, how does it change? How is my distance to the origin changing? So if I'm here, it's going to be 2, but if I'm over here, that's 6, right? So as I move along over here, I'll go from 2 to 6. So your R would go from 2 to 6, and theta, well, you're gonna, in order to get the whole donut, you have to start at 0, right? 0 degrees, and then you're gonna go all the way around and come back over here to 2 pi. So that's the whole thing. So this is gonna be 0 to 2 pi. Okay, let's submit and check it out.